Hello second years, let's start looking at some more geometry. Okay, so when we're talking about making our statements in geometry, we need to be able to use the correct language. So the first thing I want you to note is that we have two parallel lines here and there's a line crossing them both. This line is called a transversal. So you will hear the word transversal a lot in geometry and you need to know what it is. Okay, the first things we're going to look at are alternate angles. And what can we say about alternate angles? That they are on opposite sides of the transversal and opposite sides of the parallel lines. So here's our transversal, there are the parallel lines. On opposite sides of the transversal and opposite sides of the parallel line, we have one pair of alternate angles, and over here we have another pair of alternate angles. So remember, they're on different sides of the parallels, so one's below the parallel line, one's above the parallel line, and they're on different sides of the transversal. And they are our pairs of alternate angles. If we're looking at our corresponding angles now, okay, so we're going to use the same parallel lines and the same transversal. This time they're on the same side of the transversal and the same side of the parallel lines. So in this here we have four corresponding angles. So here and here they're both above the parallel lines and to the left of the transversal. In this one here, the pair of corresponding angles are above the parallel lines and to the right of the transversal. In this diagram here, our two corresponding angles are below the parallel lines and to the left of the transversal. And in this one here, our two corresponding angles are below the parallel lines and to the right of the transversal. That's a very useful thing to know. Well, why? For this very simple reason. Alternate angles are equal in size. So that means that if we know the size of one angle and we see an alternate angle, well then we can know the size of the alternate angle as well. And also, corresponding angles are equal in size. So that means that if we know the size of the angle and we see a corresponding angle, then we know the size of the corresponding angle too. Let's look at an example. So we're looking at these questions here, and what can we say? We've got angles 1, angle 2, angle 3, and angle 4. Well, angle 1. What can we say about the size of angle 1? If we look at angle 1, we can see that here, we look at angle 1, we can see that it is the same, and we look at here, that's a straight line there, so that's 180 degrees. So if we take away 120, we'll get angle 1. So 180 minus 120 equals, what is that? 60 degrees. And that is our angle 1. We always have to give a reason, and the reason is a straight line. S-T-R-I-G-H-T-L-I-N-E, straight line. Now let's look at the next one. The next angle is angle 2. Nope, 2. Okay. Well, what can we say about angle 2? If you look at angle 2 and you look at this angle here, we can see they're on opposite sides of the parallel lines and they're on opposite sides of the transversal. So that means they are alternate angles. So I can say that angle 2 is 120 degrees because it's alternate. Okay, angle 3. And what can we say about angle 3? Well, we know angle 2 is 120, so angle 3 is going to be 120. How do we know it's going to be 120? Because it's vertically opposite. And then we have angle 4. And what can we say about angle 4? Well, there's a couple of ways we could say it. We could say that, there's another P goes in there. Angle 4, we could say it's vertically opposite angle 1, or we could say that it's a straight line, and 120 there will go for vertically opposite again. So that means that angle 4 is 60 degrees, because it's vertically opposite. Now, I could also have said, I'm just looking here, a question for angle 3, that's a corresponding angle, so I could have said that 3 is 120 because it's a corresponding angle there as well. But that's that question done. Now let's look at the next one. Okay. So for the next question, we're asked to, without measuring, to find the size of the angle A. Well, what I would do in this situation is I would start drawing on my diagram there. So what can I say? I can say that this angle here, oh, that's a big mess. Let me see, get rid of that. I need a finer nib there. And I can say that this angle here, I'm going to call that B. So I can say that B is equal to 50 degrees. Why? Because it's corresponding. So if that's 50 degrees, then what is A? The size of the angle A, we have a straight line here, so I can take 180 minus 50, and that will give me 130 degrees for angle A. And what's the reason? Straight line. And that's it done.